Okay, greetings to all. Myself, Dr. M. Shakti Mohan, Associate Professor. In today's video content, we are going to discuss about the combinational circuit design. In particular, with we are going to discuss about the decoders and encoder. Okay, so we are going to discuss the basic concept of encoding and decoding, and how to design the decoder and encoder in terms of the concept and in terms of the enable line. So we'll discuss one by one. So let get into the video. I hope you can see the content screen. Okay, so first we are going to discuss about the concept of decoder. So in the previous video, we have discussed about the concept of multiplexer and demultiplexer. Actually, multiplexer is like encoder and demultiplexer is like decoder. Okay, so generally the concept is, uh, let me open a blank screen. Okay, so I hope you can see. Just listen. If it is multiplexer means it is called as a many into one. That is n is to one. Okay, well, we can say many for n and one for one, right? And demultiplex means just opposite to the multiplexer operation. That is one is to n. Okay, well, that is one into many. Okay, if you consider about the encoder and decoder now, it is like multiplexer. Okay, so the encoder is like multiplexer. That is, in the multiplexer we can say the concept is many into one, right? So but here we can say the concept is so many into many. That is 2 power n is to n. Okay, well, that is compared to the output, the input having high lines. Okay, well, so high number of inputs will be there compared to the output, right? So likewise, uh, like demultiplexer, the decoder concept will be there. So demultiplexer means one into many, right? So likewise, decoder means many into so many. That is n is to 2 power n. Okay, well, if it is n is to 1 na, that is called multiplexer, and 1 is to n na, that is called demultiplexer, and 2 power n is to n na, that is called encoder, and n is to 2 power n na, that is called decoder, right? So these are the basic things before entering to our topic. Okay, so let's get into the topic purely. Okay, so the decoder, a decoder is similar to demultiplexer but without any data input. Okay, and the technical definition for the decoder is, a decoder is a combinational logic circuit that converts an n bit binary data or code into 2 power n output data. Since I already told you, no. Okay, so decoder means n is to 2 power n is the concept. Okay, such that each output line will be activated for any one of the possible connections of combinations of input. That is what decoder, right? So in the decoder, the number of output is greater than the number of inputs, right? So that is n is to 2 power n. Okay, well, output is maximum compared to any input, right? Here it's important to note that if the number of input and output are equal in digital system means then it is called as a converter, not a decoder and encoder, right? So the converter example, binary to BCD, BCD to gray, so many examples were there. In the next video we'll discuss about that also, right? Okay, so next this is what the basic block diagram of decoder. So we have a n inputs and 2 power n outputs, and instead of select lines in the multiplexer and demultiplexer, here there is a line called enable input will be there. Okay, so here there is no select line, but instead of select line there is a enable input. Okay, so now initially we are going to discuss about a 2 to 4 decoder. Okay, so you know that compared to the output, input is minimum. Okay, but that is compared to input, output is maximum, right? So again, enable line will be there and two input, so A, B will be there, and output Y3, Y2, Y1, Y0, because it is a 2 to 4 decoder, right? So first, if the enable input is 0 na, whatever the input, okay, it may be 0 or 1, the circuit won't produce any output. So that is why for enable 0, the output will be all zeros. Okay, once the enable line is activated, after that only the circuit will be giving its output, right? So again, if it is 0 0 na, why not having the output, and the remaining and all will not having the output. Likewise 0 1 ku y1 having the output, and 1 0 ku y2 having the output, and y3 ku, sorry, 1 1 ku y3 having the output, right? And this is what the logical diagram, since we already discussed in the demultiplexer concept now, so the same kind of will be there, but instead of having the data input here, the input apart from the data input, the diagram will be there, right? So why not? Okay, so in this part the y naught output will be a bar into b bar. It is not a b the whole bar, okay, but it is a bar into b bar, and here the output will be a bar into b, and here the output will be a into b bar, and here the output will be a into b, right? This is how the decoder will be designed. Okay, so next, what are all the applications of decoder appadina? So it is mainly used in the counter systems and analog to digital converters and display systems. Okay, so in this area we are going to use the decoder concept, right? Okay, so next we are going to discuss about the encoder concept, just opposite to the decoding process. Okay, so again, you know that encoder means 2 power n is to n concept, right? Okay, so an encoder is a digital circuit that is combinational logic circuit that performs the inverse operation of decoder. Hence the opposite of encoding process is called as decoding, right? Okay, and in terms of input output, the next point will be there. An encoder has 2 power n input lines and n output lines. In encoder, the output line generates the binary code corresponding to its input value. Okay, and the actual definition for the encoder: an encoder is a combination of logic circuit that converts an active input signal into a coded output signal. Okay, so active input signal into coded output signal. So the major point is 2 power n input will be there and n output will be there, right? And here you can see the block diagram of encoder. Here I'm just mentioning the 2 power input lines and n output lines will be there, and instead of select lines we have a enable line will be there, right? Okay, so next, there is one example for the encoder design. Actually it is a 8 to 3 encoder. Okay, so the another name of 8 to 3 encoder is octal to binary encoder. Since we have a 8 input, that is d0 to d7 will be there, and depends on the input there are only 3 output will be there, that is abc. Okay, so that means you can see, if d0 having the 1 na, the output will be 0 0 0. So likewise d1 la 1 will be there na, the output will be 0 0 1, and likewise all the output will be there, that is 0 1 0 0 1 1, and 1 0 0 1 0 1 1 1 0 and 1 1 1 will be there. Okay, so now we have to calculate the a value, b value and c value. So how to calculate now, guys, listen here. Okay, so for calculating the a value, you just find out where are the 1 will be there. Okay, so through that only we can calculate the a value. Okay, so you can see here the 1 will be there, that is in the 5 6 7 and 8th position. Okay, so this one is responsible for this one, and this one is responsible for this, and this one is responsible for this, and this one is responsible for this. Okay, so that means it is the combination of, okay, so d4 d5 d6 and d7. So a is equal to, it is a combination of d4 plus d5 plus d6 plus d7. This is how we have to calculate the a value, right? This is how we got to calculate the a value. So likewise for the b value, again you just note that here one will be there, here one will be there, and here one will be there. Okay, so for this one, what is the responsible? D2 and D3, right? So b is the D2 plus D3, plus for this 2 1, what is the responsible? D6 plus D7. So likewise c will be d1 plus d3 plus d5 plus d7. Okay, we'll check the answer. Yeah, it is right only. You can see a is equal to d4 plus d5 plus d6 plus d7, and b is equal to d2 plus d3 plus d6 plus d7, and c is equal to d1 plus d3 plus d5 plus d7. Okay, so this is what the final logic diagram for the encoder circuit, right? I hope you can understand the concept. So in today's video content, we have discussed about the basic principle of encoder and decoder, that is the what is encoding and what is decoding, and after that we have designed the circuit for decoder and encoder. I hope you understand the concept of encoder and decoder. Thank you.